risk, odds ratio, and hazard ratio, how to interpret and apply these measures in research, and to evaluate the strengths and limitations of different measures in various study designs and contexts. So, for our introduction, understanding measures of association in epidemiology. So, what is epidemiology? So, what is measures of association? It is quantifies the relationship between an exposure and an outcome. In this sense, exposure means a risk factor, protective factor, or any other factor of interest, while outcome means a disease, health condition, or other event of interest. In other words, measures of association in epidemiology are statistical metrics used to understand how much an exposure might influence the occurrence of a particular outcome. So they provide a numerical representation of the strength and direction of the association, allowing us to compare groups and assess the potential impact of an exposure. So, importance of measures of association. Measures of association serve several crucial purposes in epidemiology. By quantifying the strength and direction of the relationship between exposure and outcome, they help researchers first identify potential risks. If an exposure is strongly associated with an increased risk of a disease, it may be considered a potential risk factor for that disease. Second, evaluate interventions. So, measures of association can be used to assess the effectiveness of interventions or treatment by comparing the outcomes in groups exposed and unexposed to the intervention. Third, to inform public health policies and recommendations. So, by understanding the relationship between exposure and outcomes, policymakers can develop more effective public health strategies to prevent disease and promote health. Lastly, gain valuable insights into the causes of disease and develop strategies for prevention and control. So, for example, studies have shown a strong association between smoking and lung cancer. So, this knowledge has helped to inform public health campaigns and policies aimed at reducing smoking rates. So, interpreting measures of association. So, it is important to interpret these measures while considering factors such as confounding. So, confounding, it occurs when a third variable is associated with both the exposure and the outcome, potentially distorting the observed relationship between them. Effect modification. So, when the association between exposure and outcome varies depending on the presence of another factor known as modifier. Statistical significance. The probability that the observed association is due to chance. Additionally, the clinical or public health significance of the observed associations and potential biases in studies design and data collection should be evaluated. So, type of measures of association. So, different measures of association are used depending on the study design and the nature of the exposure outcome relationship. So, common measures association include relative risk, odds ratio, and hazard ratio. The choice of which measures of association to use depends on the specific research questions and study designs. So each measure has its own strength and limitations, and it is important to choose the appropriate measure for the analysis. So we will discuss this one by one in the next slide. Relative risk. So what is relative risk? Relative risk is a measure used to quantify the strength association between an exposure and an outcome in cohort studies and clinical trial. It is calculated as the ratio of the risk of the outcome among the exposed group to the risk of the outcome among the unexposed group. In other words, relative risk compares the chances of something happening to people who have been exposed to a certain risk with the chances of it happening to a group that hasn't been exposed. So it tells us how much more or less likely the event is to occur in the exposed group compared to the unexposed group. So some of the other applications include health researchers evaluate the effectiveness of interventions, identify risk factors, and inform preventive measures. So this slide highlights the strength and limitations of using relative risk as a measure of association in epidemiological studies, specifically focusing on cohort studies. So for the strengths, direct estimation of risk. So relative risk provides a direct estimate of risk in cohort studies, where individuals are followed over time to observe who develops the outcome of interest or the disease based on their exposure status, which is smoking. So easy interpretation. Relative risk is easily interpretable as it represents the ratio of the risk of the outcome in the exposed group compared to the unexposed group. Comparison over time. Relative risk allows for comparison of disease incidence in exposed and unexposed groups over time, providing valuable insights into the potential changes in risk over the study period. For limitations, cost and time. Conducting prospective cohort studies can be costly and time consuming, requiring long term follow up of participants. Second, bias. Cohort studies are susceptible to various biases, including loss to follow up and confounding variables, influencing both exposure. It's crucial to address these biases for accurate interpretation of relative risk. Case control studies. So relative risk cannot be directly calculated in control studies, where a starting point is identifying individuals with the outcome and then comparing their exposure history with controls without the outcome. So remember, while relative risk offers valuable insights, it is important to be aware of its strengths and limitations, particularly when interpreting results and drawing conclusions from epidemiological studies. So researchers need to consider these factors alongside other statistical methods and findings to make informed decisions and recommendations. So let's proceed to the formula and interpretation for the relative risk. So mathematically, relative risk is equal to risk in exposed group, or A over A plus B, divided by risk in an exposed group, or C over C plus D. So relative risk interprets the risk of developing an outcome among exposed individuals relative to unexposed individuals. So for an relative risk of 1.0 means that there is no association or the risk of the event is identical in the exposed and control samples. While relative risk greater than 1.0 means that the risk is increased in the exposed sample. And relative risk that is less than 1.0 means that the risk is lower in the exposed sample. So For example, if the relative risk for the lung cancer among smokers compared to the non-smoker is 10, so it means that the smokers have a 10 times higher risk of developing lung cancer compared to non-smokers. So let's proceed for the sample case 1. The scenario: in an outbreak of tuberculosis among prison inmates in South Carolina in 1999, 28 of 157 inmates residing on the east wing of the dormitory developed tuberculosis, compared with 4 of 137 inmates residing on the west wing. So the data is represented in the table. So ginawa ko to para mas mapadali ang ating pag-compute. So we have the east wing, which is the exposed group, and the west wing, which is the unexposed group. So yung disease with TB and no disease without TB and the total. So dito sa sample case na to, hindi nilagay yung no disease or yung without TB. So paano natin nakuha yung without TB? So ang ginawa ko dito ay sinubtract ko lang yung exposed group with the total. So 157 minus the 28 na exposed group. So makukuha natin yung without TB na 129. So just like that. Yung exposed, which is the east wing nga, tapos yung unexposed is the west wing. Para mas mapadali po yung ating pag-compute. So in relative risk, we will use 2 steps to analyze the data. So for step 1, calculating attack rates. So the attack rate represents the proportion of individuals within a group who develop the disease during a specific period. So we can calculate it using the following formula. So for the attack rate is equal to the number of new cases. So the number of new cases, A or C, divided by the total number in the group, A plus B or C plus D. So in our example, risk of TB among East Wing residents. So 28 new cases divided by the total, which is 157 total residents. So we get is equal to 0.178 or 17.8%. While the risk of TB among West Wing residents, C divided by C plus D is equal to, we get the 4 new cases divided by the 137 total residents. So we get 0.029 or 2.9%. So interpreting this, the calculated attack rates reveal a significant difference. So residents in the swing have a much higher attack rate, which is yung nandito nga 17.8% compared to the west wing na 2.9%. So this suggests a potential association between a residing in the east wing and increased risk of TB. So for step 2 po, calculating the risk ratio. So the risk ratio compares the risk of an outcome developing the TB in one group exposed to the risk in another group unexposed. So we can calculate it using the following formula. So for risk ratio, attack rate in exposed group. So for risk ratio is equal to attack rate in exposed group divided by the attack rate in an exposed group. So in our example po, 17.8% east wing divided by the 2.9% west wing. So we get 6.1. So paano po natin i-interpret to? So interpreting the risk ratio, the risk ratio of 6.1 indicates that the resident in the east wing are 6.1 times more likely to develop TB compared po to the residents in the west wing. So here's another sample po. Itong sample case number 2 po ay kinuha ko po dun sa handout na binigay po ni Doc sa may activity. So in a cohort study investigating the association between smoking and lung cancer, researchers followed 1,000 smokers and 1,000 non-smokers for 10 years. So among smokers, 100 developed lung cancer, while among non-smokers, 20 developed lung cancer. So calculate the relative risk of developing lung cancer among smokers compared to the non-smokers and interpret the findings. So again, the data is tabulated for easier understanding po. So nandito pa din. So lagi lang po nating tatandaan yung data with the exposed group and the unexposed group. Tapos yung disease and without disease. So gaya po ng sample case 1 natin na yung without lung cancer po, nakuha lang po natin by subtracting po yung disease and the total of it. So for the calculation po, gaya din po nung sample 1 po natin. So may dalawang step pa rin po tayo. So first, step 1, calculate the risk of lung cancer in each group. So risk for smokers. Numbers of lung cancer cases among smokers, which is 100 divided by the total number of smokers, 1,000, is equal to, we get 0.1 or 10%. So for the risk of non-smokers, the number of lung cancer cases among non-smokers, which is 20, divided by the total number of non-smokers, which is 1,000. So we get 0.02 or 2%. So for step 2, calculate the relative risk. So relative risk, so risk of lung cancer in smokers divided by the risk of lung cancer in non-smokers. So we have 0.1 relative risk 0.1 10%. Sorry. So again, for step 2 na po tayo, calculate the relative risk. So relative risk is risk of lung cancer in smokers divided by risk of lung cancer in the non-smokers. So relative risk 0.1 or 10% divided by the 0.02 or 2%. So we get 5. So for the interpretation of this, the relative risk of developing lung cancer among smokers compared to non-smoker is 5. So this means that the smokers are 5 times more likely to develop lung cancer compared to non-smokers over the 10-year study period. So let's proceed to odds ratio. So what is odds ratio? Odds ratio is a statistical metric used in case control studies comparing the odds of being exposed to a particular factor between two groups. Yes, Doc? Doc? Doc, hindi ko po madinig. Hindi po kasi ng aking laptop, Doc. Sorry. Doc? Slide po, Doc. Ito po ba, Doc? Doc? No, Doc. Bali, yes, Doc. No, no, Doc. Bali, ang 1,900 po, Doc, ay nakuha ko po dun sa with lung cancer and the total. Pinag-subtract ko lang po to get 1,900 po. Ay, yeah, yeah. Sorry, Doc. Opo. Sorry. Opo, typo. 900. Okay po. Opo, Doc. Sorry. Yes, okay po, Doc. Sorry. Okay, let's proceed to odds ratio. So, what is odds ratio? Is a statistic po? Ay, sige po, Doc. Kasi, opo, Doc. Okay, Doc. Sorry po. And, oh, sorry for that po. Odds ratio means it's a statistical metric used in case control studies comparing the odds of being exposed to a particular factor between two groups, so cases and controls. So cases are individuals who had the outcome of interest, while controls are individuals who do not have the outcome. So in other words po, it is compared to the odds of an event happening in two different situations. So it's commonly used in research and epidemiology to understand the relationship between a risk factor and an outcome. So in the context po of the liver and alcohol, example, let's say, we want to study the association between the alcohol consumption and liver cirrhosis. So we could compare the odds of the developing liver cirrhosis in people who are exposed to the risk factor. So say alcohol consumption with the odds of developing liver cirrhosis in people who are not exposed, say abstainers or light drinkers. So some of its other applications include identify potential risk factors and guide hypothesis generation for further investigation. So this slide shows the strengths and limitations of using odds ratio. So for its strengths, useful for rare outcomes. So odds ratio is particularly valuable when studying rare diseases or events where the incidence rate or the relative risk might be difficult to estimate due to low numbers. Less susceptible to bias. So compared to relative risk, odds ratio is less sensitive to biases related to sampling and confounding factors, making it more robust measure for certain study designs. For its limitation, not a direct risk measure. So unlike in relative risk, odds ratio is not a true reflection of risk and, and can overestimate the association. So especially when the outcome is not truly rare. So it's crucial to consider the prevalence of the outcome when interpreting odds ratio. Limited application in cohort studies. So odds ratio doesn't directly measure incidence or risk in cohort studies, so which follow individuals over time to observe who develops the disease. susceptible to selection and recall biases. So case control studies are prone to selection bias, where choosing cases and controls might not be representative of the entire population. Additionally, recall bias can occur if cases are more likely to recall past exposure compared to control. So remember, when interpreting the odds ratio, we should consider the study design, the prevalence of the outcome, and the potential biases to draw accurate conclusions about the association between exposure and disease. So for odds ratio, for the formula and interpretation, so the formula of odds ratio is OR is equal to odds of exposure among cases, or A over C, divided by the odds of exposure among controls, or B over D. It is the same as getting the cross product using the 2 times 2 table as shown in the slide, which is OR is equal to A times D divided by B times C. So for the interpretation of the odds ratio depends on its value. So odds ratio of 1.0 suggests no association between exposure and outcome. So the odds of exposure are the same for both cases and controls. For an odds ratio that is greater than 1.0, suggests a positive association between exposure and outcome. So in other words po, individuals who are exposed are more likely to experience the outcome compared to those who are not exposed. So for an odds ratio that is less than 1.0, suggests a negative association between exposure and outcome. So in other words, individuals who are exposed are less likely to experience the outcome compared to those who are not exposed. So let's proceed for the sample case 1. So using the same sample case 1 from the relative risk, when we plug the values into the formula, so odds ratio is equal to A times D divided by B times C. So we get 28 times 133 divided by 129 times 4 is equal to 3,724 over 516. So for our odds ratio, we get 7.22. So for interpreting this one po, odds ratio, so the odds ratio of 7.22 suggests a strong positive association between residing on the east wing of the dormitory and developing tuberculosis. So in other words po, inmates residing on the east wing were more likely to develop tuberculosis compared to the inmates residing on the west wing. So here's another sample case po. Doon ko lang din po kinuha sa activity na binigay mo, Doc. So in a case control study examining the association between pesticides exposure and Parkinson's disease, 150 cases with Parkinson's disease and 200 controls without the disease were included. So among cases, 60 had a history of pesticides exposure, while among controls, 30 had such exposure. So calculate the odds ratio for Parkinson's disease associated with pesticide exposure and interpret the result. So again, the data is tabulated for easier understanding. So nandito na din po yung mga data. So using the same sample case 1 from relative risk, when we plug the values into the formula po, odds ratio A times D divided by B times C is equal to the 60 times 170 divided by 30 times 90 equals 10,200 divided by 2,700. So we get 3.78. So for interpreting this po, the odds ratio of 3.78 suggests a positive association between pesticide exposure and Parkinson's disease. So in other words po, individual with a history of pesticide exposure were 3.78 times more likely to develop Parkinson's disease compared to those without a history of exposure. So lastly, hazard ratio. So what is hazard ratio? The hazard ratio is a statistical metric used in studies where the outcome is the time it takes for an event to occur, such as time until death or disease recurrence. The hazard ratio is calculated using statistical methods like the Cox proportional hazard model, which takes into account various factors that may influence the timing of the event. In simple terms, the hazard ratio helps us see if there's a difference in the speed at which events happen between two groups, and whether the exposure to something like a treatment or a risk factor affects how quickly or slowly those events occur. So imagine we have two groups. So group A and group B. So we want to know if the people in group A are more likely to experience a certain event compared to people in group B. So the hazard ratio helps us figure that out. So aside from it can be employed in studies involving time to event outcomes such as cohort studies and clinical trials with survival endpoints. So it is also help us assess the effect of exposure on the timing of outcomes such as disease progression or mortality. So these are the strengths and limitations of using hazard ratio. So for the strengths, suitable for time to event data and survival analysis. So hazard ratio is particularly useful in analyzing data where the outcome is the time it takes for the event to occur, such as time until death, disease, recurrence, or recovery. Accounts for censoring and varying follow-up times. So unlike some statistical measures, yung hazard ratio po can handle situations where individuals are lost to follow up before the event of interest occurs and can account for varying length of times individuals are followed in the study. Allows for comparison of hazards. So hazard ratio effectively compares the risk or hazard of experiencing the event between groups exposed to different factors or interventions. So for its limitation, requires longitudinal data. So hazard ratio analysis necessitates longitudinal data, meaning researchers need to follow individuals over time to collect information on the timing of the event and the potential exposures. So assumes proportional hazard. So hazard ratio relies on the assumption that the risk of the experiencing the event hazard remains constant over time within each group. So this assumption may not always hold true in real world scenarios. So for the lastly, interpretation challenges. Interpreting hazard ratio can be complex, especially when the hazard of the event is not constant over time or when there are competing risks, other factors influencing the event, or changes in exposure status during the study period. So for the formula and interpretation of hazard ratio, hazard ratio is essentially compares the rate at which individual individuals in the exposed group experience the event of interest to the rate at which individuals in the unexposed group experience the same event. So converting that into formula, hazard ratio is equal to the hazard rate in the exposed group divided by the hazard rate in the unexposed group. So for the interpretation po of the hazard ratio depends on its value. For an hazard ratio equals to 1 signifies no difference in the hazard of experiencing the event between the exposed and unexposed groups. For the hazard ratio greater than 1 suggests that the exposed group experiences the event at a faster rate compared to the unexposed group, indicating a higher risk of the event in the exposed group. So conversely, an hazard ratio less than 1 implies that the exposed group experiences the event at a slower rate compared to the unexposed group. So suggesting a lower risk of the event in the exposed group. So for the scenario of the sample case is in a clinical trial assessing the efficacy of a new drug in prolonging survival in cancer patients, 500 patients were assigned to the treatment group and 500 patients were assigned to the control group. So over a 5-year follow-up period, 200 patients in the treatment group and 250 patients in the control group experienced the event of interest. Example, the disease progression or death. So calculate the hazard ratio for experiencing the event in the treatment group compared to the control group and provide an interpretation of the hazard ratio. So plugging the values in the formula. So hazard ratio is equal to hazard rate in exposed group divided by the hazard rate in an exposed group. So hazard rate in the exposed group can be computed by getting the quotient of the number of the events in the total of patients at risk in the treatment group, while the hazard rate in the unexposed group is getting the quotient of the number of events and the total number of patients at risk in the control group. So that is, so hinighlight ko na para mas madali lang din po yung pag-compute natin. So hazard rate is equal to 200 divided by 500 divided by over 250 divided by 500. So we get 0.4 divided by 0.5. So for our hazard risk that we get is 0.8. So how we interpret this one? So interpreting the hazard ratio, a hazard ratio of 0.8 suggests that the patients in the treatment group have a 20% lower hazard rate of experiencing the event compared to patients in the control group. So in other words po, the new drug appears to be associated with a lower risk of experiencing the event of interest. Example, yung disease progression or death compared to the control group. So this suggests that the treatment may be effective in prolonging survival in cancer patients as the hazard ratio is less than 1 po. So that's all lang po. Thank you.